Good day, fellow. Today I'm going to continue with you the concept of what of waves. Waves? Do you still remember last time I said to you we have mechanical waves and non-mechanical waves. Non-mechanical waves. Then we said that this one requires what? Medium. Then these ones, they don't not require a medium. You see, what are those? They are, example, electromagnetic waves. Bear in mind that the word electromagnetic, it is made up of electro as well as magnetic. Then by definition, what are those? Electromagnetic waves, they made up of what? Of electric and magnetic field. Which oscillate at 90 degrees in a direction of a wave. See, if I were to draw the electromagnetic wave, it would look like this. Bear in mind that it's made up of electric field as well as magnetic field. You see, it would look like this. And I have our electric field and also what? The magnetic field. Let me do like this. Magnetic field as well as electric field over there. You see, they are perpendicular to the direction of a wave. You see, we have 7 of them, if I'm not mistaken. We have 7 types of electromagnetic spectrums. You see, we say like the electromagnetic waves can be divided into electromagnetic spectrum, or can be grouped into electromagnetic spectrum. The word electromagnetic spectrum, it has to do with what? The arrangement now. The arrangement of wavelength and frequencies. See, it has to do with the arrangement of wavelength as well as frequencies. The first one is going to be what? A radio wave. I'll just write the letters, you see, because I don't have enough space. We have a radio wave. We also have microwave, infrared rays. We also have visible light. Next to visible light, we have ultraviolet radiation. Next to it, we have X-rays and gamma rays. You see? Then bear in mind that as we move from the left to the right, the frequency increase. Then as we move again from the left to the right, the energy also increase. But now if we move from the right to the left, what is going to happen now is the wavelength increase. You see? Then what does this thing tell us? It tells us that the wavelength is inversely proportional to what? To the frequency of what? Of the light. Now I'm going to give you the properties of each and every electromagnetic wave. Firstly, we have what? Radio waves. They are important for what? For broadcasting. I don't have space. Let me do it like this, or let me just erase. Let me just erase. Let me just erase. Okay, I think it's better now. Okay, we have radio waves. Okay, they are used for what? For broadcasting, especially when watching a television. Then we also have microwaves. Those are used for communication and also when heating some food. Communication. We also have infrared waves. Those are used for digitals in our computers. You see, we also have now a visible light. It is reflected to us, this one. Hence now we can see because of it is reflected. Hence we can see images and everything. Then now we also have UV, ultraviolet radiation. Radiation. It is used for what? For sterilization of equipment. Okay, we also have X-rays. They are used for what? To scan. Lastly, gamma rays. Those are used for what? They kill bacteria. Let me say bacteria. You see now, they kill bacteria. What I'm going to do now, I'm going to go back to the visible light. Okay, there are some colors that we can see on the visible light, those colors we say they're rock beef, beef. See, we have the color red, orange, yellow, green, indigo, and violet. Same applies if I were to write those here. Roig, sorry, roig, roig beef. See, it's going to be roig beef like this. Sorry, not like this. Roig beef. Yes, it's red, orange, yellow, green, blue, indigo, violet. Same applies. The color red has more wavelength compared to blue. But now if we move from left to right, the color blue has more frequency compared to the color red. See, I hope you understood the concept of electromagnetic waves. Thank you.